Welcome back to math class, students. We're going to continue our journey into statistics by looking at something with a funny name called a MAD. So it's another measure that's going to help us compare two different populations to each other. And it's not mad like, hey, I'm mad. It's mad, and you're going to see what that means.
Did you know that although Arctic wolves can survive in the toughest conditions, still, they're an endangered species? Let's say you're part of a research team gathering data on Arctic wolves. The mean pack size is an important characteristic of any wolf population. This doesn't have anything to do with how friendly the wolves are, or not. We're talking about averages. First, you collect data about a Canadian wolf population in a region called the Low Arctic. You find that the mean pack size is 6 2/10 wolves, with a mean absolute deviation of 1 3/10. Next, you find out about a wolf population in Greenland, way up in the high Arctic. Despite its name, Greenland is pretty snowy. Maybe it should have been called Whiteland. Here, the mean pack size of the wolf population is 3 3/10, with a mean absolute deviation of 0 4/10. So, based on your findings, which population might be at greater risk? Why? How can you use statistical measures to compare populations?
Burning questions, guys. Everyone wants to know. So, start a new entry in your table of contents. Start on a fresh piece of paper. If you don't have your notebook, just grab any old piece of non-toilet paper and make it happen. Although it would be really funny, and I would actually laugh if someone did their notes on toilet paper and text me a picture of that. Not a challenge, but you know, not exactly not a challenge either. Anyway, so we are going to talk about mean absolute deviation. How can you find and use MAD to compare populations? All right, so I really like this example that I found. Kyan surveyed two groups of people. He asked them how many siblings, how many brothers and sisters they each had. And he found that one group had an average of 2 siblings and another group had an average of 2 siblings. So the groups he asked was like basically the same, or the data basically the same. So that's a nice thing about MAD, what we're going to learn about today, because it gives us a clearer picture. So here's the data from the first group. This kid said, I got 1 sibling, 2 siblings, 3 siblings, on and on and on. And then here's the second group. We got a couple only children here. So was the data basically the same? No, you can see that the data here was much more spread out from the mean. And remember, the mean, the average was 2. We got like 4 only children, and we got like this person's got 5 brothers and sisters, whereas this is like no only children, and like the maximum number is 3. Okay, so we can use a dot plot to compare these two groups as well. And if, okay, so here's a different graph, like number of pets. Okay, so this group has number of pets right here, and the average is 3.5. And this person has number of pets with an average of 3.5, or this group. But if we look, this is way more spread out. This is closer together. So the MAD, the mean absolute deviation, tells us how spread out the data is from the mean. Is it really spread out like this, or is it bunched around the mean like this? We call that a measure of variation, just like when we were talking about interquartile range and spread and things like that, because it talks about how much the data varies, like how spread out it is. So again, here, they have different means, but we can see this group of people with missing assignments, like number of zeros in the grade book, is really bunched together, and this group is really spread out. If there's a large variety of data, then it's going to give you a bigger MAD. If there's a smaller variety, it's more bunched together, it's going to have a smaller MAD. So go ahead and pause and copy this business down right here. All right, so the MAD is the average of the distances between each number and the mean of the data set. And so it basically tells us, like, are the numbers close to the mean, or the numbers far from the mean? All right, so let's go back to the Kyan example and his asking people how many siblings they have. So remember, both groups had an average or a mean of 2, but if we put them on a dot plot, we can see that this group is really bunched together and this group is really spread out. The second group is actually going to have the greater MAD because it's more spread out. So how do you find the MAD? I know you're just like dying to know, right? So the first thing you're going to do is find the mean. The second thing you're going to do is find the distance as an absolute value, because we're only going to use positive numbers here, of each number from the mean. And then we're going to find the mean of those means. No, we're going to find the mean of those distances from the mean. It sounds more confusing than it is. It's actually not that hard. All right, go ahead and hit pause and write all this business down. All right, so again, we're going to find the mean. We're going to find the distance from the mean by subtracting. We're going to only use positive numbers, and we're going to use a chart to keep us organized. And then we're going to find the mean of all those differences. So yay, guys, we get to find the mean twice. Oh, you guys miss me, huh? All right, so go ahead and watch here. So here's the first group of people that he asked, and I'm going to use a chart kind of like this. And luckily for you, you're not in school right now because your homework would actually look like this, but you're off the hook on homework, so good for you. So I'm going to unpack my numbers here. So my numbers from the chart are 1, 1, 2, 2, 2, 2, and 3, and 3. And all I did there is just unpack them. 1, 1, 2, 2, 2, 2, 3, 3. Okay. Now I'm going to find the average, or my mean, and the way I do that is I add them all up and divide by the number of numbers. Okay, 1, 2, 4, 6, 8, 10. 10 plus 6 is 16. So I have 16 total, and my number of numbers is 8, so I'm going to go 16 divided by 8 and get an average of 2. Okay, to find the distance from the mean, I'm going to go 2 minus all these numbers, and I'm only going to use the absolute value of that, which means I'm just going to use the positive version of it. So 2 minus 1 is 1, 2 minus 1 is still 1, 2 minus 2 is 0 all day long. 2 minus 3 is -1, but again, I'm going to keep it positive, and there you go. All right, and then the last thing I'm going to do is find the average of those numbers. So I add them all up, 1, 2, 3, 4, okay, and I divide by the number of numbers. I am going to include zeros because zeros are numbers as well. So I have 8 data points here, and when I divide them, I get half, or 0.5, or 8 is 1/2, or 0.5. All right, let's look at that second group. So again, I'm going to unpack it. I'm going to put all the only children on here. Then a 1, and then a 4, a 5, and a 6. Okay, just unpack that right from there and spread it out there. Okay, let's find the average. 0 plus 0 plus 0 plus 1 plus 4 is 5 plus another 5 is 10 plus 6 is 16. And we know this already that, surprise, surprise, when we divide by 8, we're going to get 2. We knew, it says right here, and we knew from the beginning they had the same mean of 2. But I just wanted to review how to do that. All right, distance from the mean. So I'm going to go 2 minus 0 is 2. And then it'll continue to be 2. 2 minus 1 is 1. 2 minus 4 would be -2, but we're keeping it positive. And so even if you want to go big minus small, 5 minus 2 would be 3, and 6 minus 2 would be 4, like that. All right, let's find the mean absolute deviation now. So let's add all this up. That would be 8, 9, 10, 11, 14, 18. So my total would be 18. I'm going to divide by 8 numbers. I cannot do that in my head, so I'm going to reach for my handy-dandy calculator. And I'm going to get 2.25 as my answer. So, and I can compare that. So I have 2.25 for this group that's way spread out, and I have 0.5 for this group that's close together. So even if I couldn't see the individual numbers, but it was like, hey, this group has a MAD of 0.5, this group has a MAD of 2.25, I could immediately know without looking at the dot plot or looking at the numbers that this group is way more spread out. And yeah, I just said that, so there you go. See, bunched together 0.5, way spread out 2.25. Okay, let's put one in our notes. So go ahead and hit pause and copy this down. Make yourself like a little chart. You'll survive. I'll wait. Okay, now that you got your chart on here, we're going to put our numbers on here. I know I didn't before, but you can actually start over here. So I'm going to go 4, 5, 5, 6, 6. And then I'm going to run out of room, and that's okay. 7, 8, And then then I'm just going to divide this up and make it bigger because I have 3/8 and a 9. And it's a good idea to like count and make sure you got everybody. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I got everyone. All right, so now we're going to find the average. So we're going to add all these up and we're going to divide by 10. I used my calculator, I added those up, and I got 65. I already counted and saw there was 10 little kitties, or 10 litters of kitties here. And then when I when I divide that, I get 6.5. Okay, so that's my average. All right, distance from the mean, so now I'm going to subtract. I'm going to go 6.5 minus 4, and I'm going to keep it positive always, so it's 2.5. I subtract there, I get 1.5. I subtract there, I'm going to get 0.5. I'm still going to get 0.5 over here, and now I'm going to get 1.5 and 2.5, like that. Now I need to find the average of all this business. So I'm going to grab my calculator and I'm going to add all of that up. All right, so I add all that up, I get 14. I divide by my 10 numbers in my set, and I get a mean absolute deviation of 1.4. So there's 10 litters of kittens here. Aw, how cute is that? Like this mama cat had 4, this had 5, this had 5, and so on. I know my average number of kitties in the litter is 6.5, and they're all pretty close. I mean, there's, 6.5 being the average would be right there. They're kind of close to it, So we have a 1.4 mean absolute deviation. All right, let's do one more in our notes. So go ahead and hit pause. Like puppy pause, kitty pause. Haha. All right, write all this down. Okay, we're going to take these numbers and we're going to put them in this little top part again. There you go. Aren't they beautiful? And again, make sure you just add like an extra little box on here to get them all. All right, we're going to find the average. We're going to add all these up and we're going to divide by 10 because there are 10 numbers. And again, it's a good idea to count and make sure like, oh, there's 10 numbers. I have 10 numbers here. I'm good. Well, hopefully I'm doing this right because I don't have anyone to yell at me when I get it wrong. But I added it up on my calculator. I got 81. I divided by 10 numbers total, and I got 8.1 then as my average, or my mean. All right, distance from mean, so now I'm going to start subtracting 8.1 minus 6. I'm going to get 6.1, and so on and so on. I'm going to pause the video and make that happen. All right, so check your work against mine. So when I subtracted, these are the numbers I got. And now the last thing we need to do is find the average of all this business right here. So I'm going to use my calculator. I'm going to add all this business up. All right, my Dollar Tree calculator told me I got 41.2. I hope that's right. I divide by 10, and I get 4.12. And let's just round it to the nearest tenth, shall we? And we're going to get 4.1 when we do that as our MAD. So when we look at this, that's kind of a high MAD, right? So we had like a low of 2 and a high of 15. So we have way more variability here. We have a MAD of 4.1. versus kitties had a MAD of 1.4. So kitties in the litter were more close together and more consistent in their numbers, whereas puppies were really spread out. Okay, so which group had the higher MAD? That was puppies. Puppies had the higher MAD. So go ahead and hit pause and actually write that question down. Sorry, I forgot to tell you that. All right, and what does that represent? If you have a higher MAD, that means the data is what? Oh, not everyone all at once now. What is it? It means the data is more spread out and farther from the what? What does the M in MAD stand for? The mean, so it's farther from the mean. And that's it for things you're going to copy into your notes. So go ahead and hit pause if you haven't yet and write that business down. All right, so grab a scratch paper because you need to actually like practice and try this out. We're not going to do a million examples because I know this is kind of tedious. I'm going to have you do 2, okay? 2. You can handle it. I promise you. So grab a piece of scratch paper, you know, a napkin, a paper plate, whatever it needs to be, and let's, like, you know, make this happen. So we're going to look at some buildings and then like a skyline. So if we measure the buildings in some area, we're going to get 60 feet, 58 feet, blah, 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 blah. Okay. And so go ahead and write down all the heights. I'm actually going to modify this chart a little bit. So we're going to make it look more like the one that we used in our notes. So just, you know, sneak in a little mean there, sneak in a little mad there. It really doesn't matter exactly how it looks, but you do need a chart to stay organized. So hit pause and copy that down, and then go ahead and work the steps. Start by finding the mean of all of this and write it down. Then subtract all these numbers from the mean and put only positive numbers there. And then find the average of all of those and put them there. And go ahead and round to the nearest 1/10 of a foot on these guys. Okay? All right, so go ahead and actually try and see if you can come up with the right number. Pause, 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 pause. Okay, so hopefully I didn't mess this up, and hopefully you didn't either. When I added all these numbers up, I got 591. I divided by 10, I got 59.1 for my mean or my average. I subtracted and got all of that mess right there. I added all that mess together and I got 27.2 divided by 10, and I got 2.72. And since I'm rounding to the nearest 1/10, that gives me 2.7. Okay, one more. So let's look at another city skyline. So same deal. Make yourself a little chart, but modify it. Like sneak in a little section for mean and, you know, mad. And we're going to round to the nearest 1/10 again. So hit pause, give it a try. If you didn't quite get it last time, it's easy to mess up. If you like mess up one tiny little number, it throws the whole thing off, unfortunately. But go ahead and hit pause and try it one more time and see if you can do it by yourself. Okay, well that was really fun and exciting, right? All right, hopefully you got what I got. So I added all this up and I got 449. There was 9 numbers this time instead of 10, and so I got 49.888 going on. And when I round that, I get 49.9 as my final answer. So that's my mean. I subtracted and I got all this fun stuff. I added that up and I got 34.9. I divided by 9 and I got that, which rounds to 3.9. So hopefully you made that happen as well. So let's look at those two skylines. The first one was 2.7. The second one was 3.9. What do the mads say about the distribution of heights? What would the skylines of each of those cities look like? So I want you to think. So this means on average, each building was 2.7 away from the mean. So like, you know, 2.7 up or 2.7 down, okay? And this one is 3.9 away, so same deal, like 3.9 up or 3.9 down from the average. So which one would be more spread out? Goodness, plane flying overhead. All right, now that all that background noise is done and the plane landed in my backyard, not really. I can see that this skyline would be more even and this one would be more up and down. Okay, last one, you do not have to calculate mad. Let's just compare one more together, okay? So if you've ever gone and gotten frozen yogurt, a lot of times you see them weigh it afterward. Like they put some in your cup for you and then they weigh it. If it's not one of those self-serve places, which, you know, with coronavirus, it'll be interesting to see if they have those kind of things anymore, where you, like, you know, everyone touches the things. Somehow I don't think so. But anyway, so if you know, you're a worker at your job and you have to dole out yogurt and they say, okay, we want them to be like the same size. So every time you serve up a medium yogurt, you weigh it and they write it down. So at the beginning of the week, here's the size in grams, okay? At the end of the week, here's the size in grams. If we calculate the mad from the beginning of the week, we get 3.7. If we calculate it from the end of the week, we get 2.6. So do we keep this person on at the yogurt shop or do we fire them? Are they getting better at serving yogurt at the same exact size or are they getting worse? Let's think about that for a second. Okay. So 3.7 means on average 3.7 grams away from the average. And at the end of the week, he was only 2.1 away, he or she. So did the person get better? Yes, they do. So they improved. So because the MAD got smaller, they're closer on average to the average. All right, what would it mean if the serving sizes had a MAD of 0? Like if you had a chart here and you worked it out and you got 0 as your answer. That would mean that you hired a machine to serve your yogurt because they would get like the same exact number every time, like 79, 79, 79. And the average would be 79, and you subtract them and you'd get 0, and you'd get a MAD of 0. So if you ever end up with a MAD of 0, that means all the numbers are exactly the same. All right, guys, that's it. So what I want you to do is revisit the EQ, which is, how to find MAD and what it tells us. And I gave you a little scaffold to help you out. So write it down, revisit the notes, fill in the blanks, and take a picture of these beautiful, beautiful notes and prepare to text or email them to your teacher at the end of the lesson. Yeah. So hope you enjoyed the super exciting topic of MAD, and I will see you next time in statistics class.